Demonstration problem. An anti-tank weapon fires a 3-kilogram shell horizontally, and the shell acquires a speed of 50 meters per second after traveling 90 centimeters to exit the barrel. Assuming the shell was accelerated uniformly, what net horizontal force acted on it? We draw a picture of the weapon with the shell inside. We label the variables that we know: mass of the shell, the initial velocity of the shell is 0, the displacement of the shell in the horizontal direction while it is being acted upon by the force is depicted here. The force is provided by the expanding gases behind the shell while it is in the barrel. After the shell exits the barrel, there's no longer any force being applied to it and the problem is over. At that time, the final velocity, it is in the x direction or horizontal direction, is 50 meters per second. The givens are: the mass is 3 kilograms. The mass of the shell is what we know. We do not know the mass of the weapon. Therefore, we will be applying Newton's laws to the shell. The initial velocity is 0. The final velocity when the shell exits the barrel is 50 meters per second. The displacement is 90 centimeters. We must convert that to basic units, or 0.90 meters. The unknown is what is the net force in the horizontal direction, or F net of x. What equation or equations do we need? It asks for the net horizontal force, or F net of x. So F net of x, we note that velocity changes. Therefore, the first law does not apply. We write Newton's second law along the x-axis. F net of x is mass times acceleration in the x direction. We know the mass. If we can find the acceleration in the x direction, we can solve for the net force in the horizontal direction. We write a sub x, or just a, as final velocity minus initial velocity over the time. But there's a problem with this. We do not know the time. So instead, we write final velocity squared is initial velocity squared plus twice the acceleration times the displacement. Now we substitute into the equations. We have two equations. We first substitute into v sub f squared is v initial squared plus twice the acceleration times the displacement to find the acceleration. Once we find the acceleration, we will substitute that into F net of x is mass times acceleration to answer the question. Substituting for v sub f squared, we have 50 meters per second. Quantity squared is the initial velocity squared, or 0 meters per second squared, plus twice the unknown, the acceleration, times 0.9 meters. We simplify that. 2 times 0.9 is 1.9 meters. And then we solve explicitly using algebra for the acceleration. We get 2,500 meters squared per second squared divided by 1.8 meters. This gives us meters per second squared, as it should, and to 4 significant figures that gives us 1389 meters per second squared. We then take F net of x as mass times the acceleration in the x direction and substitute this result in for the acceleration along the x-axis. We get that the total force along the x-axis is 3 kilograms times 1389 meters per second per second. We realize that a kilogram times a meter per second is a Newton. And so we get 4167, but we must round that to 3 significant figures driven by the number of significant figures in the givens. And so our final result is that the total force along the x-axis is 4170 newtons.